Cool. So today, first, we will try to understand the definition and the normal buzzwords or the keywords that we hear a lot around AI side, and then we will try to see that how exactly we can use those for our testing and automation scenarios, right? So there are a couple of keywords first we should understand. This is nothing related to interview and all. This is just for your understanding, okay? So when you will try to explore more, these concepts will help you better. So first we will start with the artificial intelligence, which is very common that we all are aware of, right? But to put it in a very simple way, artificial intelligence is a way where we try to make our machines think and act like humans. Like, so when we say think and act like humans, that means the logical thinking supposed to be there. It should enhance or increase its capability by learning the data and patterns, right? When I say learning the data and patterns means, for example, when we go through some analysis or maybe when we try to take some decisions, basically those decisions are derived from our experience or data, right? The same thing we are expecting in AI, that when machine take decisions, those should be derived from data and patterns. That is the main objective of artificial intelligence, where the decisions should be derived from your patterns and data. That's why whenever you look into a AI ML role or any role which involves a lot of LLM AI, then usually it deals with a lot of data, and that's where your data engineering, data science, those roles also comes into picture, because your AI is completely driven by data, right? That's why whenever you are trying to act your machines to take decisions as per the data and patterns, then it is basically your artificial intelligence, right? Just to give you a more perspective to it, let assume you have a scenario on your test automation where you need to click on the login button, right? And then you need to check that once your login is successful, you are able to see the welcome message or not. This is how we basically work with our automation. Then we write a script where we basically click on the login button and then do a validation or check with assertions to make sure that the welcome message is present or not. Now let assume tomorrow the button or the UI changes a bit. Okay, then what happens? Your basically your XPath identification or however you have identified your web element, that may change, right? In that case, what we usually do, we usually try to make sure that our changes has been reflected in the code, correct? So now what we expect the AI to do? We expect our AI to basically go through the changes of its own and try to derive the reason behind the failure, that means the root cause analysis, and then perform the necessary changes. That means whatever a human can do, whatever a test automation engineer would do to debug the issue and solve it, the AI should also be able to do it. So now you must be thinking, then how artificial intelligence comes into picture? Just assume if your AI is not aware of any exceptions, then how it will even derive that what kind of solution I can go for. So basically, whenever your UI changes happens, it may throw a element not found exception, no such element exception, anything, right? Still element exception. So now those are basically your informational data, right? Which is being fed to artificial intelligence machines. So now when the machine will take decision to fix this, it will first check the exception, go through the existing data and patterns that, okay, I can see that stale element exception happens due to this region. So that is the data. Now it will go that, okay, what the 2 months back the similar issues appear and the fix was like making some change in the XPath. This is the pattern. So basically what now the machine will do, it will go and make the fixes according to the data and patterns, right? These two are very important terminology when we discuss about AI. And this is a very typical example where you can relate like how exactly your, when they say AI driven testing, this is exactly the expect. So now if your exception details are not properly given to the AI as a context, or maybe your past execution results is not shared with the AI, then definitely the fix or the RCA that it will do may not be up to the mark, right? That's why whatever data you are giving and however you are feeding it the history to recognize the patterns is very critical. Makes sense, right? So this is all about your artificial intelligence in very simple language, right? The next terminology that usually comes with AI is machine learning, right? Machine learning is actually one part of AI. So that's why we say it like a subset of AI, right? And in this subset, we specifically focus where our system will basically learn the patterns from historical data instead of following the hard-coded rules, right? That means what we will do, we will feed our ML algorithms with examples instead of instructions, right? A very typical example would be, for example, predicting flaky test using historical execution data, identifying test failure caused by environment issues rather than code bugs, clarifying bug severity automatically by analyzing previous tickets. Those are basically your ML related tasks. So now, as it is a subset of AI, right? So wherever we talk about AI, we talk about recognizing patterns, right? So now the ML algorithm will help us to do that recognizing patterns in a more defined or precise way, right? So now let me give you a proper example with automations, right? So when we say machine learning is a subset of AI where systems learn patterns from historical data instead of following hard-coded rules, what do we mean by that? That I can tell that, okay, whenever you get no such element found exception, basically you need to make the changes in the page according to the DOM, right? So basically what your AI will do, it will go to your page, download the entire page source, try to figure out the DOM structure, right? And then it will try to see that how exactly it will make changes so that your code will work. This is the expected behavior. But now let assume we have fed it with last 3 months of data. And in that data, it has been mentioned that this particular test case has failed multiple times, right? And usually, whenever it failed, it's not because of any issues, rather than it's really a defect. So instead of changing your XPath, it should raise a defect over there. Because from the pattern or historical data, it has been seen then that the issue is not with kind of any change in the locator, rather than it's a real defect that keep on reappearing with some specific device or some specific browser. So now what your ML algorithm will do, instead of directly going to the page, downloading the source, identifying the XPath, it will not waste time over there. It will go through your historical data and figure out, okay, the XPath is pretty much working fine in the last three failures also, but there is a catch that in last one, we have seen that it has been basically identified as a defect. So that's why what it will do, it will may go through the defect and try to figure out that what could be the possible reason, and then try to advise how we can fix the same. This is one of the application where your machine learning comes into picture, because in this your ML algorithm is helping you to take the decision according to the historical data and identifying a pattern. So that pattern, you are not feeding it, you are not telling that, okay, go through this history and this would be the pattern. That one it will automatically recognize of its own, right? That is the important thing to understand. So you are not feeding it the pattern, you are feeding it the data. Pattern identification will be done by ML algorithms, right? Similarly, identifying a flaky test. For example, if a test is failing since last in the last 100 runs, the test has failed maybe 20 times, right? And most of the time the test failed, and what fixes we do, we didn't do any fix, and after some days it automatically started executing because there was some defect introduced by some another team. It got automatically fixed, right? In this case, next time when it fails, basically when you prepare your report, it will automatically add a statement that in the last execution we have seen that no action has been taken from the automation team and it has been fixed automatically, right? So this is what we are expecting our ML algorithms to do, to go through the historical data and this and identify a pattern to help us in our day-to-day task. So this is one of the example I have given which you can go through. But I guess the example I have given does make more sense in the testing perspective, right? So after AI/ML, the third point that is quite common is basically the generative AI, right? So generative AI is a little bit more addition to the existing AI and ML that we have learned. So in AI ML, whatever we are doing, like going through the data and recognizing patterns, right, performing actions. So in generative AI, what basically it does, it will definitely go through your data. It will definitely go through the patterns. Everything will happen, right? But along with it will help you to generate new content. Now that content could be any text, right? Any images, videos, code, anything, right? So if you want your AI to perform the analysis, go through the data and generate some text, image, videos, or code, then it is basically part of your generative AI. A typical example would be you want your test case generation happen through AI. So what you will basically do, you will provide your requirement document to AI, right? And then you can ask it to generate some test cases for you. When the test case is generated, you can again ask your AI to generate some test scripts for you, automation test scripts for you. When generating test scripts, if some of the services are not present, you can advise generative AI to create some mock for it, right? And then once the execution done, summarize the test results and send it to us. This is what your generative AI is basically designed for. So how generative AI is the most buzzword we are seeing, because generative AI gives us the flexibility to interact with AI in a more useful manner. Your chat GPT, Gemini, DeepSeek, whatever chat options we use, all of those are generation of text, right? We use Nano Banana for generation of images, right? There are a lot of options to generate images, videos. I guess InVideo is a very good one to generate video. So there are a lot of applications that has been developed in the AI space are basically generative AI, which generate us some maybe text code or anything, and then it is behind the scene using the AI ML concept. Now, in all those things, there is one thing which little bit stand out of all of them is code, right? Because generating code can be done in the chat, but nowadays what they are doing, instead of asking your chat GPT or DeepSeek or Gemini to generate your code, what they do, they try to create some code generation tools like GitHub Copilot, right? Amazon Q Developer. Those are the code generation tools which can be tagged into your IDE. That means you don't have to kind of go to the chat and then again copy paste. Rather, you can just vibe code with these code generation tools, right? That's why generative AI is basically the starting point where the code generation tool come, and code generation tools are the starting point for your vibe coding. So all these three things are cyclic process: generative AI, code generation tool, vibe coding, right? All the things stand together, and vibe coding only happens when your this code generation tools are basically being tagged with your IDs, right? We will go deep dive into that again, but yeah, this is all about your AI, ML, and generative AI. Makes sense, right, folks? Let me stop the recording here.